In this lecture, I will discuss two aspects of web application security: authentication methods and application flaws. Web application security is a big area, and this lecture is only intended to scratch the surface, to give you a flavor of the relevant security issues. Client authentication refers to the way a web browser identifies a user to a web server. I will discuss four client authentication methods: basic, digest, certificate, and forms-based. There is a fifth method specific to Microsoft Windows called Integrated Windows Authentication that I will not discuss. First, let's consider HTTP basic authentication. This form of authentication is defined in RFC 2617. It is a very simple form of authentication that uses the concept of server realms. A realm is a set of resources on a server that are grouped together in the sense that the same login credentials will provide access to any resource within the realm. When a client attempts to access a web page in a realm, the server responds with an HTTP 401 response, indicating that authentication is required and providing the associated realm name. The browser then prompts the user for the credentials for the realm, and the credentials are then sent back to the server encoded in base 64. Base 64 is a type of encoding designed to convert binary data to a text representation. It is not a form of encryption and is trivial to decode. Consequently, credentials sent via HTTP basic authentication have no confidentiality unless they're protected by HTTPS. Other security considerations for this form of authentication include the limitations that there is no concept of lockout or maximum login attempts, nor is there any provision for logout except by closing the browser. Also, basic authentication is vulnerable to replay attacks, which simply consist of sending the username and password with any request for a resource in the realm. Overall, we can see that basic authentication is very weak from a security perspective. However, it has the advantage of being a very simple protocol and is supported by all major browsers. Due to the limitations of basic authentication, digest authentication was developed. It is also defined in RFC 2617. Digest authentication is essentially an upgrade to basic authentication that addresses the replay problem associated with unencrypted credentials by using MD5 hashing to protect credentials. It accomplishes this through the use of a nonce that functions as a salt value when the client sends an MD5 hash of the login credentials to the server. A nonce is a number used once in a cryptographic protocol. In this case, the nonce is appended to two intermediate hash values, which depend partly on credentials, and is then hashed again. Since future login attempts would use a different nonce, even if an attacker obtains the hash response from one interaction of the target with the web server, the response cannot be successfully reused by the attacker. Thus, digest authentication solves the replay weakness of basic authentication. However, the nonce itself is not encrypted. Thus, an eavesdropping attacker can intercept the nonce along with the hashed response and crack the password using conventional password cracking techniques. Other security considerations for digest authentication include the fact that it inherits the same limitations of basic authentication, having to do with the lack of any concept of account lockout, max login attempts, or user logout. Additionally, since the server does not authenticate itself to the client in any way, digest authentication is easily subject to a man-in-the-middle attack, where an attacker mimics a website, retrieves a nonce from the real website, sends the authentication request to the victim along with the nonce, and then passes the authentication response provided by the client to the real site, thus gaining access. You're probably familiar with the use of certificates to authenticate a web server to a client browser, but they can also be used to go the other direction, to authenticate a client machine to the server. In certificate authentication, they function to authenticate a user to an application running on the remote server. The process proceeds in several steps. First, the client requests a protected server resource, such as a web page. The server then responds by sending its certificate to the client, which the client verifies. Next, the client sends its certificate to the server, which the server then verifies. Once all of these steps are complete, the server provides the client with access to the requested resource. From a security perspective, this protocol is highly secure due to the protections inherent in SSL and TLS, although there are various attacks against different versions of SSL and TLS. In general, we can say that this form of authentication is sufficiently strong that the best point of attack is probably the client machine itself. If an attacker can compromise the client machine through some other means, perhaps a social engineering attack, then the attacker has access to the certificate stored at the client side and thus is in a position to authenticate to the server as the user of the compromised machine. The last type of authentication I will discuss is forms-based authentication, which is probably the most widely used method on the internet. In this type of authentication, HTML forms are used in application web pages to gather user credentials and perform a login function at the beginning of a session. Subsequent requests to protected resources must use some form of session token, such as a session cookie. The authentication process itself works as follows. First, a client requests a page, such as a login page. The server then responds with a page that includes HTML form content. The user completes the form and selects a page button that initiates the submission of the form data to the server. Processing code on the server examines the supplied user credentials and responds either with an error page or the requested page. Subsequent accesses to the server utilize the established session token. From a security perspective, forms-based authentication is somewhat attacker-friendly because the overall security relies on proper software development techniques. In other words, the web application protected by forms-based authentication is only as secure as the developer made it. For example, lack of input validation may enable cross-site scripting or SQL injection attacks. There are various vulnerabilities such as these that may be present in a web application, and scanning web pages for such opportunities and vulnerabilities is one of the preliminary reconnaissance steps an attacker will take when devising an overall attack strategy against a particular target. We now consider several categories of web application vulnerabilities. Directory browsing is a feature of web browsers allowing viewing of directory contents when a URL points to a directory instead of a specific resource. In general, there are three ways a web server can respond to such directory requests. First, the server may respond with the directory contents, allowing the user to see the files in the directory and accessing them directly. Second, the server can respond with a default web page if the corresponding file is present in the target directory. Typical default file names are index.html, default.htm, index.php, etc. The third response option is to return an HTTP 403 forbidden error response. In general, we can say that a web server should not be configured to permit directory browsing, unless there is a specific application requirement to provide it. This is because it is likely to do more harm than good because files that should not be publicly accessible may be inadvertently left in such directories. It's easy to find web servers vulnerable to directory browsing using Google because the rendered HTML pages typically have a title containing the phrase index of and page content containing the phrase parent directory. Here's a query to look for these page attributes in the .gov domain. Note that you can easily manually check a target server for this vulnerability by simply trying common directory paths, or paths constructed by truncating URLs that are known to work on the target server. Another category of web application vulnerability is username harvesting. the process of enumerating a list of valid usernames for an application. Such a set of usernames, even without passwords, can be valuable to an attacker because the associated passwords can be obtained by brute force, or it may facilitate social engineering attacks or authorization bypass attacks. Several methods are available to attackers depending upon how the web application is designed. First, differences in error messages in cases of wrong usernames versus wrong passwords may leak information regarding usernames. Instead of saying something like bad username or password, the application may simply say bad username. If we see that error for an attempt to log in as user A, but a different message, such as incorrect password, when we attempt to log in as user B, we can conclude that user B exists on the system. Another mechanism is URL-based errors. A web application following a failed login attempt may redirect back to the login page with a URL parameter that varies depending on the previous error. Even if the login functionality leaks no information regarding usernames, we may be able to use other parts of the application. For example, the password reset page may report that a username is invalid if we request a reset. Or the user sign-up page may be designed specifically to tell us if a username is available. Also, if directory browsing is enabled, we may be able to retrieve the contents of the directory containing all the user subdirectories, which will directly reveal usernames. Command injection vulnerabilities allow the execution of commands on the server via malformed client requests. One type of injection is operating system command injection. This mainly applies to web applications implemented in Unix shell scripts, such as Bash or Perl, and is not very common today. Such scripts might execute a shell command using the system command with arguments based on user input. Because Unix allows for multiple commands to be submitted on a single line, using a semicolon to delimit them, it is possible to inject a second command by including a semicolon and the text for the desired command in the input field. SQL injection is similar to OS command injection, except that the target is a back-end database. This type of vulnerability is very common today due to the prevalence of SQL-based DBMSs used with web apps. Vulnerable applications permit users to input extra characters that can have various effects. For example, a query intended to retrieve data for one user based on a value provided by the user, such as an account number, can be altered to provide data for all users by injecting a string equivalent to a logical OR that always evaluates to true. In other cases, the extra characters may inject a second command, which enables the attacker to accomplish anything permissible under the credentials being used, such as dropping tables, adding user accounts, etc. The final category of web application vulnerability I will discuss is cross-site scripting. In cross-site scripting, an attacker injects browser scripting code, usually JavaScript, into a web application which the browser runs as if it had come from a trusted site. This attack exists in the first place due to the same origin policy enforced by web browsers, which prevents code from one server from accessing data from another server. Without such a policy, it would be trivial for an attacker to use script code from one site to access sensitive data in your browser while you are browsing other sites. To bypass this restriction, the attacker has to find a way to deliver their malicious script code from the target web server, such as your bank. There are two general ways to do this. The first way is called reflection cross-site scripting. In this form of attack, the script is delivered at the time of attack, usually in the form of a malicious URL that a user is tricked into selecting. The URL contains embedded script code using HTML tags, code that will be immediately returned back from the server and executed in the victim's browser. For example, search engines often display the query string of the user when they return query results. If the attacker embeds script code in the URL as part of the query, it will be returned to the client browser, which will then interpret and execute it like any other HTML markup. The user won't even see it because scripts are typically executed invisibly to the user by the browser. In this reflected form of attack, the malicious script needs to be independently sent to each victim by the attacker. In the persistent form of cross-site scripting, the malicious script code is stored permanently on the web server and delivered as part of a normal web page to any user who requests the infected page. This type of cross-site scripting is typically conducted against online forums, where users can post text-based comments. All an attacker has to do here is post a comment containing their embedded script code, and any forum user viewing the associated topic page will have the infected comment downloaded to their browser. Both types of cross-site scripting attacks can be prevented with filtering. For example, filtering out any content containing HTML tags, although such filtering can be circumvented in various ways. For example, the attacker may encode the attack text in Unicode, which can be interpreted and understood by web browsers. But if the filter is not designed to recognize HTML tags in Unicode format, then the attack will bypass this type of filter.